Hey everybody, this is Larry. This is day 18. It's April 18th. I'm doing the extra poem. It's not quite the same on here. Maybe I'll do it tomorrow. But yeah, let's do a poem that we haven't done yet. Let's go RNG. How many poems do I have left anyway? I'm just curious. Let me check that real quick. After this loads, of course, because there's no. Oh, today we have a hard poem with a reasonable amount of downvotes. Let's kind of take a look. I have 77% solved, 2,422 poems solved. That means I have 400 or like 360 problem medium, 150 hard, and what's that, 180? So 180 plus 3, what is it? What is it? So like 5, 4, I don't know. So like I have 700 problems. So I have at one extra problem a day. It will take me 2 years to finish all of them. I don't know. We'll see what happens. All right, let's take a look at today's poem, 248. We do get a hard one today. Strobogrammatic number 3. Did we do the strobogrammatic number 1 or 2? I don't know. All right, given two strings low and high, representing two integers low and high. All right, I guess that makes sense. Where low is less than or equal to high, return the numbers of strobogrammatic numbers in the range of low and high. Strobogrammatic number is a number that looks the same when rotated 180 degrees up and right. It has up to 15 digits, which is not that bad. It's only a long range, right? Oh. Man, that went down a little bit awkwardly. Sorry. I still need more water, but all right. Okay. So sorry, excuse me. So the first thing that I want to say about these kind of problems is that the first thing is that the way that I haven't always remembered to do this, but the first thing I would say is just return something like f of high minus f of low plus 1, or low minus 1, right? Because basically this allows us to, so for any function, and in this particular function, it is going to be monotonically increasing because you cannot have negative, like you cannot subtract a negative count, right? It just keeps going up. So having this will be good, right? It's a little bit awkward because we have to handle the zeros, but we'll get to it when we get to it. And of course, these are strings, so it's a little bit awkward as well, but we do have to say that it's not that bad because they're only 15 digits. So 15 digits, like I said, it's going to be 15 digit is going to be less than 2 to the 64, so I don't really worry about it, right? So then now, how do I want to solve this actually, right? So then now we reduce this problem with a in-between thing with just one function of this thing, right? And this idea is kind of also, just to talk about a little bit more, this idea also is the same as having this idea of prefix sum, right? So then basically you have this f of high minus f of low minus 1, then you have low and high inclusive. Okay, I don't want to stress this point too much. I've done this kind of proof in the past, and today I think this one may be a little bit tricky. So we have to be a little bit more careful. How do I want to think about it? What is the strobographical number is rotated 180? So what does that mean? I wish they have a little bit more example. They just assume you know what that means, but you have to still guess a little bit. Maybe the strobogrammatic number 1 or 2 is a little bit easier, so I don't know. But my guess is that, okay. So you have, is 2 or 5? Is that like how that works? Does 2 look like a 5 upside down? That's the thing, is that I wish they just tell me instead of like, I don't know, like what does that mean, right? 3 doesn't do anything, 4 doesn't do anything, 5, maybe 5, 2, is that right? Like I said, these are really weird. And they don't even tell you which 3, right? Which is a little bit of it. But alright. So 6, 6 and 9, right? Nice. 9 and 6. Oops. 7 doesn't do anything. 8, 8, I guess makes it clear. And then these are the 2-digit ones. Okay. That is tricky. All right. Because basically, is it though? Okay, so I mean, the way that my inclination, my first inclination is to do it with dynamic programming with digit DP, right? But digit DP is kind of tricky for this one because it's not that you can't do it, but you have to be really careful about the upper bound because you're doing 2-digit at the same time, right? It's almost like if you have a similar problem is like a digit DP on palindrome, and you have to do it on half the numbers, and then you have to make sure that on the upper bound you have to be careful about it. So it's doable, but it's very error prone, right? My second thing that though, right, is that okay, it's just trying to figure out the bounds, right? Let's say these are all the numbers. I don't know that and actually they're, I mean, okay, for 2 digits this is true, but for 3 digits you also need 0 in the middle, though it cannot be a leading 0, but 0 is a component of some part of this, right? So I have to figure that out as well, which is also annoying. But okay, so there's 6 2-digit ones, and and then the 3-digit ones are just going to be the same except for, okay, so then now you have to add in one more digit in the middle, and that digit has to be whatever Strobogrammatic by itself, and it's only 1 and 8 could be in the middle. So that means that it's just going to be all, we have 6 numbers, so 6 numbers we add in, oh, and a 0, so that means that we have 18 3-digit numbers, right? I think that's right. Which is a little bit tricky. What do you do with 4-digit numbers, right? Oh, is this enough? I think that's enough. Maybe there's more. Maybe I'm missing some. No, it should be all right. So now we have 18 3-digit numbers, right? And then 4-digit numbers. How many are there? So the thing that I'm trying to figure out is how fast this grows. Sometimes it may surprise you that it doesn't grow that fast, and if that's the case, if we have 15 digits, I mean 3 to the 15 in let's say it is 3 to the 15, maybe it's a little bit more, but 3 to the 15, I'm trying to find a calculator. Nope, that's 3 to the 5, Larry. 3 to 15 is 14 million, which in theory is maybe that's a little bit too slow, but in theory, like, if the math is a little bit different, you can imagine it going a little bit slower, and then you can maybe just generate all of them in binary search or something like this, right? How many 4 digits are there, right? So we have all these 6 things, or we have 6, and each of these can have each of the 6 things in the middle, so it's going to be 36 at least, right? Because I didn't count the zeros. So each of them also adds the 0 in the middle. And so that adds 6, so it's like 42, right? So it's already 18 times 3 is not 42, so that's fine, maybe. And then how many 5-digit numbers? Maybe. Well, 5-digit numbers are just going to be 4-digit numbers times 3, right? For the same reason that we have. So it's like 126, right? And then 6-digit numbers is just 42 of those. 42 times 6, is it? Times 7, I guess. So 42 times 7 is 294. So now what do we have here, right? And I don't even know that this is right, but 4. And you can't do this during a contest. Well, I mean, I guess you can, but I am just checking out integer sequences just to kind of curious. Right? Oh, it doesn't show up. Then maybe I'm just wrong. Huh. Maybe I'm wrong. Trying to think. I mean, it may be that I'm undercounting, right? So 4 digits, it could only be 0, 1, you can't take a 3. I mean, you could take a 3 digit and then add 1 to 6, but this is just this times 6, right? So what is this times 6? Oops. Oh, this times 7 because you have to add the zeros. Yeah. So this is right, I think, and for some reason it's not an OEIS, which is actually surprising. Well, maybe the 6-digit one is wrong. What is? Oh no, it's just 4 digits. So this is 6. So this is this times 7, I guess, right? Is that fast? So 7 in theory then is 7 to the, I don't know, 8 power. Is that 2? That's still 5 million, even if I'm a little bit no. So you have 1, oh, you have 3, and then you have 6, right? So yeah, I don't think you could generate all of them. So then that means that we have to do digit DP. The reason why I don't want to do digit DP is that it is way, I don't know. But okay, fine. I just want to see if it's possible to do it any other way, but maybe not. And if it's not, then we just have to do the, if the problem asks you to do a hard thing, you just have to do it. Spend 10 minutes on it though. Okay, but yeah, and then now we just have to kind of do it, right? How do I want to write it? I think ironically I have to convert it back to a string, but that's fine, right? So the way that I know that there's a template that people really prefer for digit DP. I don't really know it because I don't memorize stuff. I mean, or at least I don't memorize stuff if I could help it. I don't memorize stuff. I mean, but I do remember the concept, right? So the way that I write it, is, think about it, is I break it into 2 parts. One is just to get the number of things with the number of digits, right? So basically, yeah. So then now we have x. And then length of x is going to be else, say, right? So then now we go, okay, how many 1 digit is there, right? Starting from 1. It doesn't include elf intentionally. You have total 0, 0, right? Total, let's just say digit of I, right? It's a little bit awkward, but it's not done yet, but yeah. Right, and then now I mean, we have this thing, but I'm curious whether I should like write something that is less analytical, right? So that I don't have to prove it. Okay, well, if x is equal to 1, then we return 3 because it is just 0, 1, and 8, right? Then if x is equal to 2, then we return 6 because we have this thing here. I think. And we'll cheat a little bit just for testing. Just because there is some parts that I don't 100% understand with respect to the 5s and the 100. So I just want to verify that from 0 to 100, it should give me 6. Oh no, it should give me it should give me actually from 0 to 100 should give me what is this? 3 times, or 3 plus 6 is 9, right? So something is a little bit wrong here, at least in my interpretation. Is 5 not equal to 2? Is 25 not a Strobogrammatic number? So if we remove 2 of these, and I'm guessing 96 and 69 is okay. I don't know. No, I need to. I wish they just defined this like more clearly. Now I'm gonna have to use a notebook just to kind of draw it out. All right, let me double check. And how do you get 3? Oh, 3 is just these. Oh, so I didn't even get this right. I was actually missing that. All right, because that's 4. Oh, 25 is 52, I guess. Okay, fine. All right, I was very wrong on this. So, okay. So now it's a little bit more, I wouldn't say it's more interesting, but it's definitely interesting, right? Because before what we said is that this was going too fast, but I was just off a little bit, right? The idea is still right. I wasted too much time though, but okay. So then there's 3 on 0, 2 is the, right? 3-digit numbers is going to be 4 of these plus one of the other 3 ones. So it's going to be just 12, right? And then the 4-digit numbers is going to be just 4 of those plus same 4, so 16, but then plus 4 more with zeros in the middle. So that's going to be 20. And 5 is going to be the 3s, but times times 4, right? Plus the 0, 0, so it's times 5, so this is actually 60. Or you could take the 4s and then times, so they both go the same way. But yeah, and then now 6 is going to be, what is it? You take all the 4 digits and then you put in 4, so, and you know, so you times it by 5, so this is going to be 100. That's why it's not an OEIS, because I did it wrong, because I was shocked to not see this on OEIS. But yeah, and this is a little bit of cheating maybe, but I am just checking the upper bound for 15, just plugging in the math, right? Alright, this is still not in. Did I do this wrong again? Let's try it. Let's cheat a little bit more then. Let's see, 6-digit, right? No, that's 5 digits, but okay, let's try 5 anyway. 99, is that right? So 1 plus 4 is 5. So 99 is already, I'm still wrong. Am I missing anything? From 0 to 100, it said 7, right? So that's 7 for am I just misunderstanding this form? I don't know. So it should be 19. Okay, that's right. And oh, maybe I just did the math wrong. So 39. Okay, and then 99. Okay, that's right. And then 99 is 199. Okay. Right, so that should be 199 or something like this. Okay, so this formula is right, so we're fine. But now let me revisit what we want, right? But this is going to be just 5 to the power of half of this. So it's like 5 to the power of 17. Oh, 7, sorry. Oh man, I'm just like really off today. So 5 to 7 is 78,000. So I don't really worry about this, right? I mean, we can just write, what is it? if x mod 2 is equal to, or just like, no, I don't even need to do that. I just go, if this is dig of x minus 2 times 5, right? Is that right? Well, except for 3-digit. 3-digit, why is 3-digit just 12? Because you take all these and you take, okay, so, or you could take the 3 single digit and then add the 4 on it, right? Is my base case wrong? Why is this 1 for 3? Maybe it's just, okay, fine. Because there are no leading zeros, is that for this one? I think that's why. Okay, fine. Right, and then now we can just print dig of 15-digit. Yeah. So then okay, so I was wrong on the 2 and the 5s, I guess that's right. But now you can see that you can generate all the numbers and it would take only 187,500. So let's do that. I think that's basically the idea behind this one. It's way easier than doing it with digit DP, which is why I tried to avoid it for so long. However, I did kind of, like I said, I just didn't understand the 2 and the 5s. That's why I was complaining a little bit about it, but it wasn't unreasonable after you saw what happened, is because I just simply did not understand the 2s and the 5s in action. Okay, so then now we have, all right, now I can remove this, I don't care. We don't, so now we have this, so now we have yeah, how do I want to write this? Let's just say we have a gen, right, for generating, and we have yeah, this is so annoying to write. Yeah, it's fine. I think we just maybe just have 2 generations. I think I don't need to simplify it that much. Yeah. Okay, so then now this is for odd number of digits, right? And then we have current, and then now we can say for so now we have odd number of digits. So now we want to yeah, that's fine. Then now we want to, for each one, generate these wrapping it, right? So odd number of digits means that so the left side and right side is going to be uniquely determined. Oh, this is so annoying. Okay, fine. Okay, we just add the first digit. Now you can't do that because of leading 0. That's why it's a little bit awkward. That is really awkward, actually. How do I want to? I mean, it's not hard. Like, we can add more if statements if I have to, but I'm just trying to be really careful about it. And the thing is, you can generate all the numbers offline, even if you really prefer. But man, this is so annoying. Let's do even number of digits first. Okay. So then now we have the current numbers, which we will just have the left side, so it's 1689, and then now we just generate more, right? So for x in maybe we have like numbers, right? For x in, was it 1689, current dot append x, gen current dot pop, right? Just I could rewrite this a little bit cleaner, but that's general way of doing it, right? And then here we can write okay, we take the current, right? So yeah, okay, fine. Shift and add. So for x in current, g shift g add, and then now we do it again but backwards for the second half. Shift let's just say f of x, right? And maybe f of x will be like this, and now we have, and this is wrong, I messed up, I should have 0. And then now maybe f is equal to this lookup of 0 0 1 1 6 9 8 8 9 6, right? Who keeps pinging me? Alright, and then now this should be good. So gen, we just now gen with let's kick it off. Oh, this is the even number of digits, so it has to be 1689. Right. It's a little bit awkward still, even in the whatever, right? And then now let's take a look at print numbers. Except for this doesn't ever terminate, so we have to be careful, right? I didn't finish writing this. So yeah, if g is greater than high, we return. Otherwise, if g is greater than or equal to low, then that means that we can numbers.append g, right? Something like this. Let's spin it real quick. Current is not defined. Okay. Why do I write it like this? Alright, so this looks good for the even digits, right? Dick is not oh, because I coded F. Okay, that's fine. Yeah, I mean we have to rename it. Let's go with G. Actually, I think that's fine. I think we did it. We didn't do it end up doing it this way, so we can just do length of numbers technically. We don't even need to sort, but it is not a good way. It's just our way, right? So like we're almost there, but we didn't do the odd numbers, which is why it doesn't work. So we have to kind of do it again for the odd numbers, which is very awkward. But maybe this is just the way we need to do it, right? I should say something like this, right? How do I kick it off? The first digit is going to be the middle one. And the middle digit can be anything, right? Nope, it's just 018. And then now gen 2 of empty string and an X, right? Just gen 2. 0 for X in current. I guess it's the same thing here. maybe I should, you know, should maybe write that into a code. But in any case, this is not quite right because we have to have the middle. So we shift and add the extra or the middle. I called extra for some reason, but it is the middle. And then now we could do the same thing. And I think that is actually good enough. I think I just didn't handle the middle case very well in my head earlier. Yeah, let's try it again. Well, infinite loop somehow. Well, not loop, but why is that? We shift, we add, we love, we laugh. This one is a little bit awkward. Because, yeah, if length of current is equal to 0, and x is equal to 0, we continue, I think. There we go. I mean, it's wrong, but at least it's, I don't know, something. Yeah, let's sort this and then we can kind of see where I'm going wrong. I guess I don't need this anymore. Okay, so I do a lot of 11s. Right, oh, I called Gen again. It should be Gen 2. That's why. Oh yeah, and yeah. That was just lazy copy and paste. Okay, so there you go. Looks good. I don't know that this is fast enough. It's fine. I'm gonna submit it. If it's not fast enough, we'll just rewrite it. It's not a big deal, right? I mean, it's fast enough, but yeah. For example, this one. The thing I would say is that you can. The code is pretty ugly. You can refactor some of this, right? Like just this stuff, for example. But I'm not going to because I'm lazy and tired. But you can do it. The technology exists. But the way that I would write it is that actually I would rewrite this as maybe like something like this, maybe, so that it generates only once. The low in the current is a little bit awkward. We have to change this to like if length of is greater than 14. Oh no, 7 is it? If it's 8, it has 16, right? So something like this. Oh, not length of G, length of current. I guess we can also write it that way. If G is greater, then you go to what's it, 9/15s. So we can just write it 1, 2, 3, 1, 2, 3, 1, 2, 3. That's, I suck at this. Right? If this is greater than that, then we return, then that's fine. Right? And then now here we can just oh yeah, we should do it once. So if length of numbers is greater than 0, we return. Otherwise, then we would fill this up, right? So then now we can do something like calc. We can. I just want to make sure that this works. I mean, otherwise it's just a binary search, right? We can even put a binary search sorting in here. Yeah, you could see it takes 5 seconds, huh? Do I print out too many numbers? Is this upper bound too rigid? I don't know. What was my other submission time is faster. That is actually surprising. Why would it be so slow? Huh. I mean, maybe the print is slow, but we'll see what happens when I take out the print. The sorting shouldn't do anything. What I should have done is print the length of it though. Am I doing something weird? It takes 5 seconds. Standard out. Oh, it takes 5 seconds because I never update stuff to numbers. But how? Is this the global? Oh, I just never append. I just never appended. Okay, fine. Gee, whoops. So that's why I was calculating every time, because it expects it to be okay. That's just me being dumb. Yeah, see now it's only still longer than I would like, but it doesn't recalculate it every time. And I think we just kind of, I don't know, right? But yeah, then now we can do a binary search on bisect left of low -1 on numbers, and then we can do a bisect left on numbers high minus this, and then we can return it. Maybe I'm off by 1 here. I have to think. Yeah, I'm off by 1 here because of the zeros. Because this gives us the 0 index. I think that's why. The 0 is always a weird case. Yeah. I guess you can just return this then. Because this returns like the 0 index or something, right? But okay, maybe that's still wrong. Why is that? That includes the index. So this should be right. Maybe it's bisect right to count the number of them. Because it should be that number plus 1, I think. And by that logic, this should be. I don't know if I'm right here. I'm getting the indexes a little bit awkward. But let's give it a submit. I think I'm wrong actually. But oh no, I'm right. I actually am surprised. But I mean, this is one of the things with pre-calculating, right? Is that you don't know the texture of the input. They could, if they just do, for example, if they just do 0, if they do the worst case, which is maybe this. Right, this would be very slow if we had to pre-calc. Oh, I miscounted. We have to pre-calc every time, but because we don't have to pre-calc every time, this is fine. Right? Like if you have 5 of these, then it's going to time out on here. But I mean, I don't know. It doesn't really matter. Yeah. What's the complexity here? The complexity here doesn't really matter that much because everything is pre-calculated. But you can say that where n is the number of digits as we calculated is roughly speaking, it's 5 to the n over 2, right? So you could kind of like do a logarithmic trick to be like 2, 2 to the n is exponential, but n is very small, so which is fine, right? And we generate all positive numbers because the numbers only grow 2 to the 15 or whatever. And I think we printed out the size of it before, which is like 300,000 or something, right? So only 300,000 numbers, so we're fine with generating them in this way. And well, we also do a sorting at the end. We probably don't need to do it with I don't know. I mean, you could do the generation in number, but it just makes it way more complicated with the odd even bit the way that we did it. Yeah, that's all I have for this one. Let me know what you think. And yeah, pretty interesting. Let me take a look at it, discuss. Is there back? Yeah, okay. I guess that's what. I was curious whether anyone did the. I don't know if you call it dynamic programming, but maybe you do. I don't know. But yeah, I was wondering if anyone did it with digit DP, but like I said, I'm just confused about the 2s and the 5s. So anyway, that's all I have for this one. That's all I have for today. It's a hard problem. I spent okay. Wow, 40. Wow. I don't know. Maybe I'm slipping. That's all I have for this one. Let me know what you think. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye bye.